So let's start recording and share screen. Okay. Good evening to all of you. Welcome back to Machine Learning Stack. Okay. Today we are going to learn a very important topics and concepts, and it's very interesting as well. Okay. So welcome to week 5, lecture 2, data science in Python and machine learning coding dojo. Due this week by Friday morning. So the 3 assignments are pending by this week, Friday morning. This is Abalone, pre-processing exercise, pipeline activity, project 1 and part 5. So these all please submit by Friday morning or maybe before that. Okay. Recap. In previous lesson, you have learned about what is machine learning and its different types that we have discussed: supervised, unsupervised, application of machine learning. We have application most popular types. What is train and test split and why we split the data set? What is a model validation, right? So if you have any confusion in previous lesson, you can stay after the class and you can also ping anytime on the Discord. TS are available and me also available, and you can also email me anytime if you have any confusion, any query, and book 101. This is highly recommended. Okay, so today we have a 5-minute breakout room discussion. This is just from your previous lesson. Okay, so everybody try to participate in this. One person can be the driver and others can be the navigator, and decide one person who is going to answer the question in a group. Okay, so let me open the breakout rooms. Okay. Hey, how many? You did not join any group?
Sorry, I just got in. I'll join my group now.
Okay. Good luck. Hey, Olivia.
Sorry, guys, I didn't mean to leave the breakout room. I stopped.
Fine.
Okay, anybody from your group want to answer the question? What was the most important thing you learned in previous lesson? Anyone?
Defining your features versus your target. You have to that's
Okay.
what.
Okay. And what type of problem is this? Is this regression or classification?
Oh, it's classification.
Classification.
Great, good job. And we have also learned, like in the previous lesson, we have learned about the model validation as well. Like why we are splitting the data set, right? Into X train, X test, Y train, Y test. Okay. Is everybody there?
Yes.
Okay, great.
So
Yep.
Okay, anyone else from any group?
I'm pretty sure we were group 4. Our answers were Y. The Y feature would be the prediction of diabetic,
Mm-hmm.
and then the rest would be the X.
Mm-hmm.
And this would be a classification problem because our goal is to predict a classification, like a yes or
Yeah.
no question instead of a
Yes.
numerical question.
Great answer. Okay, this is great. Okay, so we will move ahead. Our today's agenda is what is data pre-processing and what is data leakage, what are pipelines and column transformers. So today we are going to learn very important topic. And let's start with the data pre-processing. So what is a data pre-processing? Data pre-processing, if you remember the previous lesson, you have seen the life cycle of the machine learning. So first step was you already get the data. We have done the collection of the data. Now we will start the pre-processing steps. Your pre-processing steps contains these combination of these 3 steps. This is first one is your explore the data set, and then cleaning, and then transformation. So we have 3 steps in this. In this, you need to take care one thing very carefully whenever you explore the data set. In these, we have the following steps like check and drop the missing value, check and handle the duplicates. So these steps should be done before, should be done before data set split. These are the only 2 steps which you can do before data set split. It is never recommended handle your missing value, use any FILNA method, any simple imputer. You are going to learn today the different methods. Never ever use it before data set split. What is the reason behind that? It will cause a data leakage. Okay, so that's why never ever fill the missing value before your data set split. You can check it and drop the missing value if it's a 1 or 2 and it is not required and it's an extra code or junk code, then we can drop those rows of record. Okay, but never try to handle it. And you can also drop the duplicates. This is also the good at this place. And after that, you will split the data set. Now, when you split the data set, we are going to do now data cleaning. In this, what we will do, we will check and impute the missing values using your mean, mode, and okay. And you can also use the most frequent strategy of the simple imputer in this. And you can also check for the inconsistency and handle those in this. Okay. So these are the steps you need to do only and only after data set split. Anybody have want to guess when we should use the mean strategy and when we should the mode or median? Anyone? Any guess?
You would use like the mean strategy for numeric data that involves floats, and then use median for integer values when you don't want anything after the decimal point.
Yes, great answer. Okay, and you can also check for inconsistency. Inconsistency, for example, if you have the difference between the your records name, like we have one categorical, like the column you have, in that you have a female, at one place it is starting with the lowercase, at one place it is starting with the caps, the uppercase, like that. And there is a maybe a different value, or maybe there is an outlier, one value is very, very different from the other records. These are all the type of inconsistency. Never forget to check these steps. These are mandatory. Okay. And data transformation, in this what we do, now you have explored the data set. You check the missing value, you check the your duplicates, you have handled the missing value, you have handled the inconsistency. Time to transform the data now. Okay, so you will handle the categorical data using one hot encoding, okay, and label encoding. And you will handle the numerical data using standard scaling, mean max scalar. Okay, so these are the data transformation part which you apply only and only after doing these two steps. Any questions about the data pre-processing steps? Any confusion? Why we cannot handle the missing value before the data set split? Any confusion? Okay, if still something come up in your mind, please you can type the question in the chat, and you can also stay after class. Okay, so first of all, we are going to discuss about handling inconsistency. So in this, what we are going to do, if you look at this table, this is the gender table. In this, we have a categorical data. If you look at this is the male. It is starting with the uppercase. But if we look at this value, it is starting with the lowercase. And same with the female, if you look at this example, right? So this is a kind of inconsistency in your data set. Before changing it into the ordinal or 0-1, or maybe we are using other strategy, we need to make it consistent. Okay, so how you will do that? You can use the dictionary method here. Okay, in this you will say like male, I'm changing this to this one. Okay, the same if it's a lowercase female, I will change it into this one. Okay, and then we will again assign this dictionary which I have changed. To remove the inconsistency, I will replace my this column with my new this one. And I will make a changes in my or in this data frame. So you can see the result. So this is your consistent data. You can handle it after data set split. But if you want to check the inconsistency before split, you can also do that, because there is a no kind of data leakage in this. Okay, because we are not placing any new value into this. Okay, any confusion in this in handling inconsistency? Any question? All right, so let's move ahead. Okay, so now we have seen how we can handle the inconsistency in your data set. Okay, now we will talk about handling your numerical missing data, how you are going to handle it. So if you look at this example, right? So this is the table, right? This is number of advertisement, and these are the total sales. So if the number of advertisement 7s are done, the total sales will be of $40. And you can look at this is 0, right? We don't have any value here. or it can be blank as well. Okay, it can be NaN as well. So what I will do here, I will impute my missing value using here simple imputer. This is the very, very popular method to handle the missing value. In this, we have a different strategy. This is mean, mode, and median. And I'm using here mean. What it will do, it will take the average of this one. Okay. And then it will fill it with this value. And this is your, now we have handled the numerical missing value. So you can use a simple imputer, or I can use it only after split. Anyone?
After the split.
Yes. And why we should use it after the split? Anyone?
Avoid data leakage.
Data leakage.
Yes, correct. Okay. So this is very important, right? And apart from this is also very important. Okay. Whenever you are using the strategy like mean, mode, median, you need to justify why I am using this mean strategy here instead of mode and median. So in your core assignment as well, when you are using the mean strategy, please make a new text cell and interpret it, justify it in 1 or 2 lines. Like I'm using it for the numerical, like the data, right? I'm using it because these are the floats number. I'm using most frequent because I have a categorical data. Apart from this, there are other reasons as well. Like we prefer the median when we want to take care of the like distribution, when your data distribution is not in a normal phase. It is skewed either on a left or right. In that case, we always prefer the median. This is also another reason. If you want to like write it in more detail. But it's a very important, make your habit whenever you are using any strategy, always justify in 1 or 2 lines in another text cell. Okay. This will be very helpful for you in BELT exam as well. Okay. Okay. So now till so far we have seen how to handle the categorical numerical data and inconsistency. Now we will talk about the categorical missing data, how we are going to handle it. If you look at this example again, we have a one column in the data set model. Okay. This is showing the models of the different cars. If we look at these, the second value is missing. We don't have anything here. How we are going to handle this? We are going to use most frequent strategy. Why I am using most frequent? Because my data is now, the column is in the form of categorical. It's not numerical. So that's why we will use most frequent. So the most frequent strategy, what does it do? Which value is repeating most of the time column, it will fill the value with that value. Okay. So if you look at this result, it is filled by 4 when I have applied this strategy. Okay. So this is the way how you can use the simple imputer for the categorical column to handle the missing value, and how you can use it for the numerical value using the mean strategy. Okay. Again, I would highly recommend create a new text cell in your notebook. Okay. And interpret the result. Justify it. Why you are using most frequent here? Why did you choose this technology? Sorry, strategy. Okay. So this is very important. Okay. Any questions still so far? Any question? Okay. If anything come up in your mind, you can stay after class as well. Okay. I have a one poll for you. Okay. Okay. The question is, which is the fastest and best way to handle missing value? Great. guesses? Or okay, more guesses? I got a 15 responses. Anyone else who want to participate? Okay, yes. The answer for this question is the first one, simple imputer. Fastest and easiest way to handle your missing value. Okay. So let's move ahead. Now we have talked about handling your missing data, how we can handle that. We will talk about now the steps of data transformation, how you can scale your data. If you look at this table, okay, in this, we have a name column, this one, and its weight is this, and price is this one, right? So the why, can anybody tell me by looking at this table, why I need to scale it, this data set? Anyone?
Because Python can't recognize the categories as categories. It can only recognize it as a hierarchy of numbers.
Yes.
Okay.
Any more guesses?
Because the model will assume that it's already scaled anyways, I think.
Okay. Any more guesses? Okay. So we need to scale the data. The first answer was good. I would like to add here, if we are saying our model does not like the categorical data, we need to change it into the numbers. That is something we are doing the transformation using other technology, other methods. That is like we are using ordinal, we are using one hot encoding. You will see this step after this slide. Okay. So here we are talking about the scaling. The scaling means all features should be at a same unit. Okay. There should not be the huge difference in the units. If you look at this table now, look at this value, right? And look at this value as well. Okay. So sometime the greater the value, your model think about it to giving the greater magnitude means your model may think more, it is a most important value. Okay. Your model start giving the weightage to that, higher the magnitude. So it should not be like, you can see here is a very units, right? In both of these. So that's why we need to scale it. So it should not be like our model in this did not like look at the higher magnitude only. So that's why we scale the data. This is the reason. And after that, we will convert this into one hot encoding, and you can also scale it if it is required, like in categorical data. Scaling the data is always good habit and best practice to do it. Okay. Any questions about this? Okay, I would like one more line here. We use the standardization library, standard scale the data. Okay. Okay. So now it's a poll time again. So, okay. The question is when we should do scaling of the data set. Okay. More cases. Okay. Mhm. Yes, I got a 16 responses. Okay, the answer for this question is we will scale the data set split. Okay, the reason behind that, because you are going to scale it after handling like your missing value and you are checking duplicates and everything. Okay, and that we always do after split. Okay, to avoid the data leakage. Okay, any confusion in this? Like why we should do the scale, when we should do the scaling of the data set?
So you said the scaling would be after the data is split?
Yes, yes.
Okay.
Okay, because we will scale the data only and only once you handle the missing value, right? So, and we are handling the missing value only after data set split. Otherwise, it will cause a data leakage.
Okay. Thank you.
Does it make sense?
Yes.
Great. Okay. So now we will talk about the encode the data. Okay. So this is very important again, how we encode data. Okay. In this, we have two methods. This is very popular, one hot encoding and ordinal encoding. Okay. Now we will see, look at the next slide. Look at this example. This is, we have a table with the ID and colors. It's our categorical one. Okay. When I will import one hot encoder library in my Python and apply this method, it will convert my all colors into this form, 1 and 0. Okay. So if you look at it carefully, I have how many colors? 1, 2, 3, 4. Okay. But blue is repeating. So this means I have a 3 colors. So first of all, one hot encoding will make a number of columns depending upon your these values. Okay. And at which place your this value is true, it is going to be 1 at that place. And all colors are going to be 0. Okay. If you look at this second result, it's a blue here. So this place under this column, it is going to be 1 and others are going to be 0. So this way, one hot encoding works. It will make a lot of columns, how many values you have, and assign a 1 if it is a true according to the this column name. So this is the way how your one hot encoding works. Does it make sense? Any questions about it, one hot encoding? Okay, take your time. If still something come up in your mind, please ask after the class. Okay. So now we will talk about the ordinal encoding here. Okay. This is we are using for over ordinal data because categorical column is divided into data type is a 2 type, ordinal and nominal. This is a kind of nominal because there is a no order. This is just the name of the colors. But if you look at here, this is coming in order, low, medium, high, right? So it's a kind of order. If we give another example, it's like we are saying 1 star, 2 star, 3 star, 4 star. This is also ordinal. Okay. And this is also ordinal example. Now, how would you do that? You can assign, either you can use the dictionary method for this. You can assign low, your this value to 0, medium to 1, and high to 2. Or either you can import the ordinal encoding library using Python and you can apply that on the this type of your feature. and then it will convert it into your numeric value. Okay, so your data can be ready for your model building. Any questions about this? How to encode the data?
Yes, please.
Mhm.
So when we're doing ordinal encoding, do we have to start with 0 because Python uses 0 and indexing, or can we start with 1 without ruining the whole thing?
You can also start with the 1 as well.
Okay, so it'll go from
Yeah.
lowest to high. Okay, I was just curious.
Yeah,
Thank you.
low with the higher. This is just the numbers.
Just like when you're rating an Uber driver, 1 star, 2 star, 3 star, 4 star, 5 star, that's ordinal encoding.
Thanks, Ivan. Okay, so this was the like most important. Another again, highly recommended. Please justify when we should use ordinal encoding. Okay, so sometimes we also use other like the one hot encoding, and you need to choose like tell why I am using one hot encoding instead of ordinal encoding. Okay, because sometimes in your data set you have only nominal categorical column, not ordinal one, right? And sometimes you have ordinal only, not nominal. So you need to justify, create a new text cell, write at least 1 or 2 lines. I am using the ordinal encoding because I have the, in this categorical data, order in order, ordinal type. Okay. So this is very, very important. Okay.
I have a question. So
Mhm.
if we have more than one ordinal columns, do we scale them as well to kind of like put them into like on the same footing?
Yes, you can scale them. Okay.
Okay.
Like it is not going to make a very major effect in your model building, but scaling is always good. I would like to add one more example here. In this example, I'm showing only 3 ordinal data, right? If you scale it, it is not going to make a major change, right? But maybe tomorrow you have a big data, you have a more than 10 categories, right? You may have a more than that. In that case, when your model will see, let's say it's up to 12. So your, like when you change into ordinal encoding, it will change up to 12. So when your model will saw the big magnitude of that number, it may start giving the weightage to that one. So that's why it is highly recommended. Always scale your data. Okay. Does it make sense?
Yeah, thank you.
Welcome. Okay. So here, this is an example how you can justify your result. Okay. So when the categorical feature is ordinal, we can use only ordinal encoding. Okay. Because each value should reflect the sequence like this. Okay. And this is your for one hot encoding. Okay. So now it's a poll time again. We will go to poll number 3. Okay. So one hot encoding is a process to great. I got a 16 responses. Great. Okay. So its answer is convert categorical values into numeric value. Okay. One hot encoding is only and only used to handle your categorical data. Okay. If you already have the numerical feature in your data set, you don't need to do anything with that conversion. Okay. We only scale it and handle missing value in numerical. Okay. Any confusion in this? Why we use a one hot encoding? Any questions? Okay, take your time. Okay, so now we are going to discuss very important topic, what is data leakage and how it happens. It's very important. Okay. So now how data leakage happened? If you right here, in the first step, I am loading the data set. Okay. Then I am making a copy here. This is also the best practice. Never forget to make a copy because we don't want to touch the original data set. We will not do any manipulations in this. And then what I am doing here, I am applying the pre-processing steps on this data set. Okay. I did not split it. I'm just applying the pre-processing steps on this. So what were the pre-processing steps include? It was including you are handling missing value, you are applying the simple imputer, you are applying the transformation, everything. Okay. So this is the wrong step. Never follow it. Okay. Because we don't want any data leakage and we also want to save the copy of the your original data frame. So this is a wrong practice. Never ever applying your pre-processing steps except you are checking missing value and duplicates. Okay. So this is not recommended. This is wrong process. Otherwise, there will be the data leakage definitely in your model. And whenever you will give the new data to your model, it will fail. The reason behind that, because you already leak the information during training of the modeling. Okay. When you will train your model already know the every answer at that time and every information is leaking. And when you split it, right, fit to the model, so there is a data leakage. And when it will perform very good, you will get 99% accuracy. You will be happy. I made a good model. But what will happen when you have a new data set? Your model will not able to perform very well. Okay. Because during training, your model learn so much. So it will not catch your new data and it will fail at that time. So this is not recommended step. How you can avoid the data leakage? Look at this picture now. What I am doing here, we will load the data set. Again, make a copy of these and then we will split the data set first. Okay. Here we are splitting the first and then we are applying the pre-processing steps on your test and train. Because now your values are already splitted and your training data have no information about the test data now. Okay. And test data do not have any information about the train. Okay. So now you can fill the missing value here as well. And then you can fit to the model. Okay. And so this is always recommended. First of all, you need to split it and then fill the missing value, all pre-processing steps, and then fit to the model. Here you need to take care only one thing. Okay. Your fit, you only need to fit the data onto the training, not to the test. Okay. We only fit the data onto the training during modeling. Okay. And not onto the test data. And your scalar should only be fit on the training set to avoid the data leakage. This is the reason. Okay. Any confusion in this? This is very important topic. If you have any confusion, please ask the question. Okay, take your time after class. I'm there. You can ask the question, okay? Okay, so now this is another example. How the one hot encoding can cause a data leakage if you are applying it before data set split. Okay, so what will happen? Let's consider if you have a nominal column, right? And you did not split the data. You applied the one hot encoding on that. right? And then you are splitting the information. What will happen? There are may one category which exists in the train, and it is also like copying into the test data now, because you have already like handled the missing value. In that case, I'm talking about before splitting right now. So there will be the data leakage now. Okay, because your split method will share the information, some information from the train to the test to the train. They're sharing the information. Okay, in that case, there will be the data leakage. So that's why we always recommend this method only and only after split. Okay, so now it's a poll time again. Okay, so when we should pre-process the data? Great. I got a 15 responses. More guess. Great. Okay. The answer for this question is after the split of data set again. Okay. First answer is wrong because you cannot handle the missing value before data set split. Okay. Okay. So now we will talk about the pipelines. Pipelines is used for multiple transformation on the same column. Okay. Like if you want, you have a categorical column, one column. You have few missing value and you want to convert it into one hot encoding as well. So you need to apply the 2 steps here, and then you want to scale it as well. So 3 steps are there. So this means 3 transformation you want to apply on same column. Then you required a pipeline. How it look like? It look like this. If you look at this example again, it's a number of rooms here, right? We will first talk about the numerical column. So this is the missing value. Now what I want to do, I want to impute it and then want to scale it. I want to apply 2 methods here, like the transformation method. So what I will do, I will make a pipeline for this. This is your pipeline. In this, like your dash, your dotted, this square, this is the pipeline, this one. Okay. And here I am applying the 2 methods on the same column. This is the biggest advantage of the pipeline. It fast your pre-processing steps. Okay, very fast. Okay, it helps you to do every step in one go. So then after what it will do, it will first impute it and scale it. So this is your output for this one. And in Python, it look like this. It's imputing the value and then scaling it. Okay. Now this is the example for your categorical data. In this again, there is a missing value. We will impute the missing value first, apply the one hot encoding on that. Okay. So then this is the result again. Okay. So it will look like in Python like this result. Okay. How you can do this, I will show you in the code along. Okay. So this is the biggest advantage of the pipeline. Why we use it? Because if you don't use it, you need to do it manually. How would you do it manually? First, you will impute it, and then you will scale it in another step. But if you are using the pipeline, you don't need to do anything extra. It will fasten your process. Any confusion, any questions about the pipelines? All right. Okay. So now we will talk about the column transformation. This is again important concept. This allows you to process numerical and categorical columns with appropriate strategy. Okay. And as a one parameter pass through and drop. This is for our remainder your parameter. Okay. How the column transformer work, I show you first in the picture, then you will understood the definition. Look at this. In these, you have a two pipeline. This is pipeline 1, pipeline 2. We made the one pipeline for numerical and second pipeline we made it for categorical. Okay. Now I want to transform the data. Okay. My data is ready. I have separated my object and numeric column. And then I also decided which step I want to apply on that. I made a pipeline for that. And then I will put those pipelines into the column transformation. Okay. What it will do, it will transform the data on the multiple columns at the same time, parallelly. This is the advantage. Okay. So what will happen now, you can see this is numerical, this is categorical pipeline, and this is remainder. This you can set pass through or either drop. Pass through means if tomorrow in your new data set, there is a new category added, then your model will ignore that category. It will not throw error. Okay. It will not make any changes. And if you are using the drop, then it will drop that category. It will not throw any error. Now, this is your choice, which is very important for you, and you can use that strategy. Okay. If you look at these in Python, it will look like this. So you can see it is parallelly transforming the numerical categorical data using the different transformation method. Okay. Now, if we go back to our definition now, allow you to process different columns differently, right? This is we are doing there. Here, this is first column, this is second. It is transforming in different way using, this is because numerical and this is categorical. Okay. Any questions about the pipelines and column transformation? Any confusion?
I have a question regarding the pass-through. So once we build the model and run through our data, so is there any way we can catch this pass-through data and analyze further?
Analyze for this one?
Yeah.
Yes, but like in this, if you are using the pass-through, when you are entering the new test data, right?
Right.
You already have seen the data that, right? Because our model was trained already with the data which you in the past, right? For example, if I am like train my data with the two columns, let's say house sale price, right? I have a number of bathrooms, area of the house. I know I have a two columns in that, right? Tomorrow, maybe I got a new data set. In that third column is added, right? I know about that column, but I want to my model to ignore that category, right? So this way you already know, okay?
Right.
Another example here, we're using a numerical data, and then we got categorical data that we both want to process. But we haven't talked about it, and we don't go over it in this stack. But another type of data is time series. And so that would be an example of something we would not want to transform with our column transformer. And so it would just pass through unchanged.
Okay. Got it.
Okay, so this is like how the column transformer and pipelines work. You can also like put the column transformer inside the pipeline as well. Okay, so we can use it vice versa in this case. So we will look at, you will get a again chance to look at these. So now I have one more poll. This is just the temperature check. Okay. How much did you get from today's lesson? It will help me to know how much all of you get. I will relaunch the poll again. Okay, just give me 1 second. This is, sorry about that. Pipelines are used when okay. More cases. Okay. The answer for this question is first one, right? When we want to apply the many transformation on single column. Okay. Okay, so let's move to the code along. Here, today we are going to take the diamond data set in this. Okay. And in these, first of all, we will import all libraries. This you have seen this library in previous lesson as well. The new libraries I'm importing in this is make column selector, make column transformer, and from the pre-processing package, the standard scalar, min max scalar, one hot encoding, ordinal encoder, and pipelines, make pipeline from sklearn, and simple imputer method, and set config, this one. We are using this library to show the diagram of your pipelines. So you will have a better understanding. This is highly recommended to use it. Okay. So now we have the diamond data set. We need to predict the sale price based on the given feature of your diamond data set. Okay. So it's given with the length, width, depth, and the color of the diamond and the quality of the cut of the diamond in this. So what we are doing here, first of all, we will load the data set here. Okay. And then we will look at it in this. Okay. Here we have a target value is price one in this. All other features are your independent features. Now, this is the best practice again to avoid untouch your original data set. We will make a copy and to avoid the data leakage. And then we will drop the unnamed column 0. Okay. I will do in place is equals to true. This is equal to 1 because I'm going to delete it column wise. Okay. So it will drop that because I don't need it. It is not going to make any contribution in my modeling. Okay. Now we will check the missing value here. The missing value we can see it's in caret. We have a 20 missing value, in cut we have a 21 and so on. So we have a lot of missing value in this, right? And then we will check for duplicates. There is a if there is a duplicate, we will drop it using this one. Now look at this info method. How many entries we have? Total 0 to 5399, this one. Okay. And you can also look at it. You can see the missing value here as well. Okay. I know this is very useful method, but don't forget to use this method. Okay. And now this is the describe method. Anybody can tell me why, how the describe method help us? Why we use it? Anyone?
Just gives you a lot of basic like statistical information. It can help you make like determinations by looking at it.
Right. Great answer. Okay. So now we will drop the values from the price one. Why I am doing it? Look at these. There is a 6 missing records in your target. Okay, because it doesn't make sense. I'm going to handle it. We will drop the values which is missing in your target. Okay, so you can see this is the advantage before split as well to check the missing value. But I'm not doing anything here, only checking. Okay, so now we will drop it because I am not applying any here simple imputing method. Okay, I'm just dropping it. So there is no data leakage due to this. So we can do that. If you want to really check the percentage, how many data set is left. So you can see it's a 99% is there still. Okay. Now we will split the data set. To split the data set, first we need to separate the X and Y features here. Okay. So we will drop the target column from the X and we can look set the Y as your target one. Okay. Now we will use the train test split method here. We will pass XY again. The random state is equals to 42 here. Anybody can tell me why we use the random state is equals to 42?
Oh, because it gives us the perfect ratio of 75% to 25% for train and test.
Random
Right.
state?
No. I will correct it. We use the random state because we want the consistent output. Whenever you are refreshing your results, every time it will show you the same result. This is the reason we use random state is equals to 42. The which ratio you are saying like your division of your train and test 75 to 25. This is by default, which is your train test split is doing. Okay. And if you want to change the size of that test size, you can pass the parameter here as well. Okay. 0.30 like this. Okay. You can also change the size of train as well. This will help you to change the division of the train and test ratio. But random state only and only used for consistent output result. Does it make sense? If still anybody have any confusion, please ask after class. Okay. So now we will check check the categorical distribution of the data. Now we will do using this. Xtrain dot select d types include is equals to object. Now look at the result. It is showing how many data we have, numbers, records for the ideal, premium, very good, good, fair, right? And the colors, clarity. So now we will instantiate the transformers in this. So I'm using here min max scalar. This is just we are using when you want to scale your data using the your all features. It will take the minimum value of that and maximum and then take out the result. This is used at that time. You can also use the standard scalar as well. Okay. And in this one hot encoding to convert your categorical data into numeric one. And then here is the mean imputer. We are going to use the mean strategy. This is for your categorical most frequent. And then this is the third strategy, constant. Okay. This is just to declare to show you the different type of strategy of the simple imputer. Okay. But we are not using it here in this data set. Okay. So declare only the type of strategy which you are going to use for your data set. Okay. Now we will separate the ordinal data. You can see here, this is the ordinal because it's saying fair, good, very good, premium, ideal. So it's a kind of order, right? And same with your clarity labels. So I will separate them out and make a list of it. Okay. And declare here ordinal encoder your library. Okay. And then we will make a pipeline here. If you look at this is a numerical pipeline. We will pass the mean imputer in this and then scalar 1. Okay. And for ordinal, we will pass frequency imputer in which we are using most frequent strategy and then ordinal data type. And then nominal, we are passing missing imputer again here for OHE. Here I'm using for, I think, constant, this one. Okay. So I'm using it. So for the OHE, for the nominal pipeline. Okay. And then we will make a here the make column selector for number type now. And we will make the tuple for the this one now. Numerical tuple, number pipeline, num selector. So what is your num selector? Only numerical data type. Okay. And then we will make the tuple for the ordinal and then your nominal data. Why I am making the here tuple? To pass it inside the column transformer, because column transformer will take the data plus your data transformation steps, and data transformation steps contains your pipeline, this one. Okay. So this is how it will work now. We will declare the instance of make column transformer here preprocessor, pass the ordinal, numeric tuple, nominal, and remainder is equals to drop. Okay. And then we will fit onto the X train here. Okay. You can see the result. This is your pipeline for your ordinal data. This is for your numerical data. This is again for your nominal data. Okay. So it will fill the missing value first, then convert it into one hot encoding numeric. It's your numeric one, scaling the data using min max scaler. And this is your converting your, filling your missing value in your nominal data using simple most frequent strategy. And then converting into one hot encoding again. Okay. And then we will transform the data using column transformer. Okay. And then pass X train in this. This is now my transformed data, X train. And this is my test transformed data. Okay. So we are using here column transformer instance to transform the data. But I have fitted only and only onto the X train, which you have seen in the slides as well. Okay. So this is practically how we fit and transform the data. Okay. Now your data is ready for the model. Okay. So now you can check the result. Everything is converted into the your numeric one, floating one, and there is a no missing value. Okay. So this is the way how we use the pipelines and your transformer to for the pre-processing steps. Anybody have any question in this? In pipelines, column transformer? Take your time. I will stop